So even though some of the math involved in working with them is a little bit complicated, it turns out that exponential functions are some of the most natural ones to construct to model real-world phenomena. So much so that a lot of people just assume that anything that isn't linear is exponential. Now that's not true. We've seen all sorts of functions that are not linear or exponential over the course of this class. But exponential models are extremely common. Where do they come from? Well, we know that if we have a linear function, what's happening is that a constant change in one variable leads to a constant change in another. They show a constant rate of change, and that's described by the slope. A typical example of the kind of situation where you get a linear model is if you have $20 and you get $5 more every day, then the amount of money that you have as a function of the number of days that have passed is, well, you start with $20 and then you add 5 times the number of days and you get the amount of money that you have after t days. So that's a linear model. How is an exponential model different? In an exponential model, when we have a constant change in one variable, for example, when a day passes, we have constant multiplication in another. For example, your money doubles. In these models, the rate of change is faster when the value of the function is bigger, and slower when the value of the function is smaller. So for example, if you start with $5 and you double your money every day, that's an exponential model. The more money you have, the more money you get if you double it. We can write this function where you have $5 and your money doubles every day as, well, we started with 5, then double means multiply by 2. So we multiply by 2 over and over again every day for t days. So the amount of money you have after t days is 5 times 2 multiplied by itself t times. So 5 times 2 to the t. This gives us the very basic form of an exponential model. This was a basic form of a linear model. This was called slope-intercept form. We now have the basic form of an exponential model, where we can write a basic exponential function in the form some number times some other number to the x. This form also has a name. It's called base multiplier form. You should think of the base multiplier form as analogous to the slope-intercept form, except instead of repeatedly adding something, we're repeatedly multiplying by something. So f of x equals, here's this f sub 0, which we might say f naught. Naught is just an old English way of saying 0. F naught is the starting value. It's the value of f of x when x is 0. And then m is the multiplier. It's what f is multiplied by every time x increases by 1. So here's an example of a basic exponential model and how we read the function out of a story. Here we're told that a new website is growing quickly in popularity. Every week, the number of visitors triples. The site has 10 visitors in the first week. We want to write a function showing the number of visitors t weeks after the site launches. So the word triple means to multiply by 3. Every week we're going to multiply by 3. We're going to say our m is 3. The starting value Well, we have 10 visitors in the first week. And that phrase, the first week, means that no full weeks have passed yet. So our F0 is 10. Our function then is 10 times 3 to the t. 10 visitors in the first week, multiplied by 3 once for every full week that's passed. So 10 times t copies of the number 3. 10 times 3 to the t power.